Section 11.1, three-dimensional figures and cross-sections. We're going to start off with 3D figures, and they are figures that are made up of polygons. So for example, if we are to draw a cube, we can see that it's made up of 6 different squares. So let's go ahead and talk about some terminology. So if we were to break apart the square from the cube, we can see that the face is the space inside, which we usually think of as the area, the edge is one of the side lengths, and the vertex is a corner. We'll be using that terminology with Euler's formula specifically, and it's just a way to find a missing vertice or the missing number of edges or missing number of faces if we're given 2 of them. So we'll break it apart. It is v minus e plus f. So if we take, for example, this triangular prism, we can see that there are 5 faces, 9 edges, and 6 vertices. I took a moment to number each one, but it's kind of difficult to see with all the numbers, but we can plug that into the formula and we should get 2. We can get 6 minus 9 plus 5 equals 2, negative 3 plus 5, which is equal to 2. So it does in fact work for our formula. Sometimes they'll ask, can a figure have this many number of faces, vertices, and edges? So all we have to do is plug it into the formula and see if it equals 2. So we get 4 minus 7 plus 3 equals 2. Negative 3 plus 3 equals 2, which is not in fact 2, so it cannot have this many number of faces, vertices, and edges, because 0 does not equal 2. Occasionally you'll be asked for the number of edges given a number of vertices and faces, so all we have to do is plug in what we have and solve for the missing variable. So let's start by isolating e and moving it to the right hand side, and we can then simplify the left hand side to get 66, and last but not least subtract 2 to get the e by itself. So a shape with 22 faces and 44 vertices has 64 edges. The last thing we'll be talking about is a cross-section, which is cutting a 3D figure into 2 parts. So let's take a cube, for example. Let's cut it straight down the middle, and it'll get broken into 2 different parts that we can separate. Although my drawing's not perfect, if we were to cut it in half into 2 pieces, we would get 2 smaller cubes. So when we ask about cross-section, it'll be asking what shape is drawn in the middle where it's cut in half. So it could either be this bottom part, the top part of the blue one, where it's highlighted in green, or the bottom part of the purple one, but they are the same shape, and because it's a cube, the cross-section shape would be a square. And that's the end of this video.